There's some terms you have to go through that we find in any measurement system, be it the tools or measuring instruments. Any measurement system will have these terms, and these terms are important for us to know. The first one is readability, and readability is how close the scale of the instrument can be read. And a very good example is when you take a ruler, ile ruler uko nayo, you take a 15 centimeter ruler and a 30 centimeter ruler. The scale ya 30 centimeter ruler will be easily read as compared to that of a 15 centimeter ruler. That is what we call readability, how easy the scale can be read. Now, list count is the smallest difference between list count is the smallest difference between divisions in a scale. Kwa mfano in a ruler, from one division to the next division is 0.1 of a centimeter. Remember, the ruler for example, the 30 centimeter ruler, iko 30 centimeters, each division having a centimeter, each division being a centimeter. But within those divisions of centimeters, we also have 10 divisions of 10 millimeters. Yeah? So if I was to look at those individual divisions, from one division to the next of this 30 centimeter ruler is 0.1 of a centimeter, and that is the least count of this ruler, the least measurement that this ruler can measure. That is what we call list count. You see that different scales and different instruments will have different list count. A vernier scale will not have the same list count as compared to a micrometer, as compared to a ruler. They will all differ depending on the type of scale you use. Yeah. Now, range is that measurement the smallest to the largest measurement that instrument can make. You'll find that in this case, the ruler, the example of the ruler, the measurement is from 0 to 30. So that is the range, the minimum to the largest value that instrument can make, the measurement that it can make. That is what we call range, dynamic range. We have sensitivity. Now, sensitivity is how the instrument, the ratio. In short, it is the output over the input. It represents or indicates how much the output of an instrument or a measuring element changes when the quantity being measured changes by a given amount. So when I change the physical property that I'm measuring, kama ni temperature, how much the output changes from the measuring instrument, ama how much the reading changes, is what we call sensitivity. So it's the output or the input, that linear movement, the ratio of the output to the input. Repeatability is the property of an instrument such that if I take a measurement, the same measurement over and over again, when I get the same results, then that is what we call repeatability. We repeat the same measurements over and over again so that we are able to determine the accuracy of that instrument. For example, if I'm measuring pressure, measure pressure and nikapata the first pressure and 50 bar. When I do the same measurement, the same quantity and the same pressure, then I get that my output is 30 bars. I do the measurement again, I get that it's 60 bars. You'll find that instrument is not accurate. So there needs to be calibration. But if I measure the same quantity over and over again in an ipatia 50 bars, then it shows that my instrument is accurate. And that property of repeating the same measurement and you get the same results is called repeatability. We have another property known as accuracy. How close your measured value is to the true value. Or the degree of the measured, how the measured value, how wrong it might be, in that sense that if I have a workpiece, I'm a piece of metal, and I measure the actual value is 10 centimeters. And then I take my ruler and I measure, I take my measuring instrument, and I get that the instrument inanipatia that the length of that metal is 10.4 centimeters. Then how close that value ambayo nimepata is to the true value is what we call accuracy. And when we talk about accuracy, then we introduce the concept of error, which we express as a percentage. Even accuracy is expressed as a percentage. So it is how close that measurement that you get is to the true value. Now precision. Precision is the limit to which a signal can be read. It is the limit to which a signal can be read. It is how close the values that you get are to the same. If I measure, for example, or let me just give a random example. Tukicheza dart. When I'm playing dart and then I throw my darts, I might not be accurate. Naweza kosa kugonga ile bullseye, but I can be precise. Now, what do I mean by this? If my dart land almost at the same place, sio lazima ikuwe katikati, but if they land almost at the same place, then it is possible to, then that means that I'm precise. I might not be accurate, but I'm precise. How close the measured value agrees to one another, ama how close they are to each other, the groupings of those measured value. So if I'm measuring and I get that my let's say I'm measuring temperature, and then the first reading comes at 30 degrees, the other reading comes at 31 degrees, and the other reading is 29 degrees. You'll see that my measurements are around the same place. And the true value might be 35 degrees, 40 degrees, meaning that my instrument is not accurate, but it is precise. It is giving me the same reading, the same. When I measure the same quantity, those quantities are close to each other. So we call that precision. We have resolution. Now, this specifies the smallest change in a physical quantity that changes, that causes a change in the measurement. If I'm measuring temperature, that smallest increment in the temperature that will register an output in the measurement system is what we call resolution. So you'll find that different measuring instruments have different resolutions. If I'm measuring temperature, the resolution of a thermometer is not the same as the resolution of, let's say, a vernier scale. So ni tofauti, depending on the type of scale that you use, and the type of measuring instrument that you also use. Now, threshold. If I increase the physical quantity that I'm measuring, for example, temperature, gradually from 0, that input to the measuring instrument will reach a certain minimum level before the change in the output, which is being shown by the instrument, registers a reading. The reading is of large enough magnitude to be detectable. So that minimum level of the input, that physical quantity that you're measuring, that minimum level that registers an output is what we call the threshold of that instrument. Are we together? Tuko pamoja? If we are together, please unmute and say that I am present. Nisikuwa naongea peke yangu.
Present.
Okay. Now, response time. When we talk about response time, it is that time the instrument takes to register a reading. Once that physical quantity changes, and until or up to that time, the instrument can be able to give an indication of the output of that physical quantity that you're measuring. That is what we call response time. You'll find that there are some instruments that will take much more time because they're on a lag. They have lag time. They will take much more time before they register an output, and there are some instruments that if they're sensitive, if there is a change in the input to that instrument, the physical quantity that you're measuring, then the output is instant. So the response time is that time it takes for the measuring instrument to register that there is a change in the physical quantity that you're measuring. Now, when we talk about tolerance, The example that I can give is that when you go to a hardware and you buy a screw and a nut, niende hardware moja ninunue nut ya 10 millimeters in diameter, and then I go to another hardware and I buy a nut, a screw and a nut of the same diameter. You'll find that even though I have bought the screw and the nut at different hardwares, and both of them are 10 millimeters in diameter, they will still fit, because when we are machining things, there's always that aspect of tolerance. We have to include we have to include the possibility of error. What do I mean? When you're machining anything, ama ukitengeneza chochote, kama ni meza, kama ni kiti, if you want to cut a piece of metal to be 10 meters, you don't actually cut that exact value 10 meters. You cut a bit. You give that room. You give a room for an allowance. So if you want to cut 10 meters, cut 11 meters. So that when there is a problem, it gives you that allowance to rectify that problem. You might want to cut 10 centimeters exact, kisha ukapata umekata 9 meters. So there is not that room for fixing. You cannot add metal to that 9 meters to get 10 meters. Yeah? But unaweza punguza from 11 ukafika 10 meters by filing or other machining processes. Yeah, so that maximum acceptable difference between the actual quantity, the actual value of the quantity, and the value specified for it, is what we call tolerance. It is that allowable amount by which a measurement can vary. There's usually that allowance. We usually say that my measurement will be plus or minus 2. So the tolerance there is that plus 2 or minus 2. My measurement can be plus 2 or can be minus 2. So that difference between the maximum and the minimum limits, the limits now being that maximum plus 2 and the minimum limit being minus 2. So that difference between those allowable amount that measurement can vary is what we call tolerance. Now, when we talk about scales, there are two types of scales on measuring instruments. We have scales that are linear and we have scales that are nonlinear. Scales that are linear are those whose graduations or divisions, ama sections, ama proportions are equal in value and size. For example, the ruler that we have, the 30 centimeter ruler, those divisions in between those that have been drawn, that have been cut into the ruler, are equal in value, in size. Each of them is 0.1 of a centimeter. From 0 to 30 centimeters, utapata each division is 0.1 centimeters, and that is a linear scale. A nonlinear scale is that whose divisions, sections or proportions, the markings on that scale are not constant, or they're not equal in value. So utapata there are places that are 0.1 centimeter, utapata there are some places that are up to a centimeter between the divisions. So that is what we call a nonlinear scale. So we have instruments, kwa mfano permanent or moving ion instruments that measure current and voltage. They do not have a linear scale; they have a non-linear scale. So the scale from 0 hapo mwanzo zimefinyana sana. Then the scale, as it continues to increase in value, then the divisions also increase in size. Now, limits and fits. When we talk about tolerance, tulisema there is that plus or minus. Now, when we talk about that plus or minus, those two extreme sizes that of a part between which the actual size is contained is what we call the limit. So if my measurement is, let's say, 100, and I say that it is plus or minus 100, so the upper limit of that measurement will be 1 plus or minus 2. The upper limit will be 102 and the lower limit will be 98. So those two extreme permissible sizes that the actual size is contained are what we call limits. Now, the term fit in engineering is usually known as it refers to the clearance between two mating parts. So if I want to determine how that part moves, or how that part mates with the male and the female part mate, then I can choose the different types of fits. And we have 3 major categories when it comes to fits. Kuna clearance fit, kuna interference fit, and we have transition fit. The major ones are the clearance fit and the interference fit. And this diagram here just shows the terminologies that are used when it comes to fits. And I've written them in the notes that I've sent pale Google Classroom. So you can go and check what each means. Unaweza enda uandike hizo notes ukiziangalia polepole at your own pace, so that you can know how tolerance is, what tolerance is when it comes to fits. But when we talk about interference fit, and I'll use this example of a shaft and a hole. A clearance fit is one whose hole is larger than the shaft. Shimo ni kubwa kuliko shaft, so there is a relative movement between those two mating parts. So that allows these parts to move relative to each other. That is what we call a clearance fit. So this enables that assembly. This enables that assembly to be assembled easily and leaves room for sliding or rotational movement, or depending on the type of mating parts that you have. But you'll find that one part is larger than the other, so that it enables those parts to move. And in this case, the shaft diameter is smaller than the hole diameter. Now, transition fits are those that are, let me talk about interference. The interference fits are those, in this case, the shaft diameter will be larger. So shaft labda itakuwa inafika mpaka hapo. So it will be larger than the whole diameter. So you'll have to, it will require some force or some lubrication or some heating, so that you can be able to squeeze that shaft into that hole. So you'll find that this is a tight fit. So it is used to ensure that there is no movement. When you don't want a movement between those parts, you'll use a shaft that is larger than the hole. So you can either decrease the hole, or you can either increase or decrease the hole or shaft size, depending on what you want so that you are able to mate those two parts together. Now, if I want to have a fit that is in between those two, then I will have a transition fit. So it might lean more towards the clearance fit if I have a hole that is bigger. If I want, it might lean towards the interference fit if I have a shaft whose diameter is bigger. So it can be in between those two fits. Tuko pamoja?
Yes.
So using this diagram, you'll be able to go look at the notes and see that what these terms mean. Utaziona, and then you'll be able to understand. Now, there's something I'll mention, and this is usually like the reference point. This line ambayo imeenda straight, and it is known as the zero line, or the line of zero deviation. When you make a design in whatever field that you are in, you'll always have that diameter. Tunasema like, for example, let's say I want my shaft diameter or my conduit. I'm designing it and I want it to be 10 centimeters in diameter. That is what we call nominal diameter. So that will be the basic size of your diameter. But when you're machining that diameter of that shaft or that shaft or that pipe, you'll not machine it to be the exact 10 centimeters. You have to allow for tolerances. There are specific guides that give you instructions on how to kuongeza those tolerances. So you'll find that you'll have the basic size, which is represented by this shaft, but your actual shaft maybe will be 9.8, 9.5 ama kitu kama hiyo. So then you will be able to have lower deviation, upper deviation, tolerance, and all that. So every instrument, every tool that is manufactured has to take into consideration all those aspects of tolerance and allowances. Now, today's topic, sana is marking out. This is the topic I want to introduce today. Now, marking out is a process of transferring designs. When you're transferring a design onto a piece of metal by drawing lines or scratching lines onto the onto a workpiece, circles, arcs, anything that you're going to be doing on your workpiece, kuchora. Kuchora is, for lack of a better word, if you're going to transfer a design onto a workpiece, sana I'm talking about metal, but you can do that on a plastic, on wood. That process is what we call, we refer to as marking out. Now, what is the purpose of marking out? The reason why we mark out is to indicate the piece, the outline of the workpiece, how that workpiece is shaped, or the positions of holes and slots. Remember, there are kwa mfano kama zile when we are talking about castings, ukisha melt chuma yako umeisolidify, you'll find that there are some workpieces that are not regular in shape. So for you to draw an outline, you will have to mark out. You'll use certain tools to draw the outline on the surface of that workpiece. It is also used to provide a guide for setting up the workpiece on the machine. So if I want to set up my tool, my let's say shaft kwa lathe machine, and I want it to ingia kwa lathe machine up to a certain point, then I can draw a mark on that workpiece to indicate that I want it to reach up to this point. So that is one of those are the two most common functions of marking out a workpiece. Now, a very important term, a very important concept when marking out is datum, and this is usually the reference point from which all dimensions will be taken, where your measurements will be making. And this is usually easy when you have regular shaped workpieces. Kwa mfano, if I have this square shaped type of workpiece, then I can make my measurements from the edges. So that is what we call a datum edge. Kama vile unaendanga kwa kitabu chako and you want to draw lines on that book, you can start from the edge because it is easier. So when you're making that measurement, when you're drawing on your book, then and then you take the measurement from the edge of your book, then that edge is what we call the datum. Now we can have a datum that is a point. For example, when you want to draw arcs and circles, kama vile huwa tunafanya katika technical drawing. For us to make a drawing, a sketch, or anything on a workpiece, we have to have a point in which, when we use a tool kama a scriber or a divider, we can be able to make the measurements from that specific point. So it can be an edge, it can be a point, it can also be a center line. When you talk about circles, spaces that are circular in nature, holes that are circular in nature, since you cannot be able to specifically measure uwezi ekelea your workpiece onto a hole a space, then it is possible to determine the center of that hole by using center lines. So we can take the center lines as the reference from which we'll take our measurements. So a datum can be a point, it can be an edge, or it can be a center line, depending on the shape of your workpiece. Now, there's some things that I want to mention that I haven't put in the slide, and those are coordinates. Now, when we talk about coordinates, we mean the specific locations of a point, or the specific point on a workpiece. For example, when I want to make a drawing, or I want to make a mark at this specific point, and I want to tell someone else, another engineer, that hey, I want you to drill at this specific point. What I will use to mark that point is coordinates. And we have two types of coordinates. We have rectangular or Cartesian coordinates, and we have polar coordinates. So when I talk about rectangular or Cartesian coordinates, these are dimensions, or these are where dimensions are taken relative to the datums. They're taken relative to the datums at right angle to each other. So for example, if I want to know the position of this point, I will take the dimension from this datum, this edge. So I say this is, let's say, 10 centimeters, and I'll take the measurement from that point, and I say this is 5. So my coordinate will be 10, 5. So when I indicate that to an engineer, atajua that the position of where I want him to mark, or the position of where I want him to do whatever I want him to do, is 10, 5. And this is what we call a rectangular or Cartesian coordinates because you have taken the dimensions relative to the datum at right angles to each other. They are right angles to each other. Now, when we talk about polar coordinates, is where the dimensions are measured along a radial line from the datum. Along a radial line. Now, for example, I want to find the coordinate of this position at this point, upper. I'm sorry. At this point, yeah. So I will take the dimensions not from the edge, because we do not have a rectangular edge. I will take them from a point along the I'll make the dimensions. I'll take the dimensions from a point along this radius line, so that when I look at the when I indicate the position along this circle, then what I will have done is I will have taken the polar coordinates. Now, what are some of the tools we use to draw these designs, or we use to mark? The most important one is a surface table and a surface plate. Now, a surface table is essentially where unaekelea your workpiece. Remember, in the workshop, you have we have different types of instruments, and most of these machines have places where you can put your workpiece so that you are able to work on it. Now, this surface table is essentially meza tu ambayo is made of cast iron. Sana sana they're usually made of cast iron. The surface is cast iron or granite, or depending on the sana sana, let's say it's cast iron, and it is square or rectangular and has a top that have been machined accurately. Their squareness, their parallelism have been machined to a certain accuracy, such that this surface is flat from this edge to this edge, ni flat yote. And it is used to check on the trueness of the flat surface of your workpiece. So you'll find that if I want to establish a datum on my workpiece, I need a reference surface, and that surface is this table. Now, when we are using this surface table, we have to ensure that it is coated in oil. And when you go to the workpiece, you'll never find it exposed like this. Inakwanga imefunikwa na cover, a metallic cover or a wooden cover. So it is oiled, and then a wooden cover is placed on top of it to protect it from dust. But we use this to mark to ensure the trueness of the flat surface of our workpiece. We also use it to establish datums on our workpieces, kwa sababu it is flat. So when you put your workpiece over there, then it is easier. It's easy to draw or establish a datum on the workpiece. Now, if I have a smaller workpiece, then I can use a surface plate. It's the same type of material, cast iron, but it is smaller in size. Yeah, it does the same thing. We'll use it to establish a datum when you have smaller workpieces. Yeah. We also have tools known as parallels. Now, if I want to establish a surface, a datum, kwa mfano hapa, this is a datum that I want to establish, but I want it to be raised a certain height from the reference table or the surface plate, then what I use is parallels. Now, these parallels are placed here, but they will still this workpiece and the surface table will still maintain parallelism, kwa sababu these parallels are machined to a great accuracy. They have the squareness, they have flatness. Yeah, ziko sawa. They have been machined to that great accuracy. They usually come as a pair. So they usually come as a pair, zikiwa mbili, and they are of the same dimension. So depending on, let's say if I want 5 centimeter parallels, nitapata mbili which are 5 centimeters. If I want 10, I'll get 2 of them that are 10 centimeters. And they're usually made from hardened steel. So they vary in size depending on the size of the workpiece that I want to mark. Now, their purpose is just to raise the workpiece a certain height from the surface table and still maintain that flatness, some of the parallelism between the workpiece and the surface plate. Now, we have jacks and wedges. Yeah. So when I want to mark a workpiece that is irregular in shape, kwa mfano a casting or a forging, which has an uneven surface or it is awkward in shape, then it is still essential to maintain that datum relative to the surface, the reference surface, that is the surface table. And for me to do this, I need to ensure that my workpiece haichezi, it is not rocking to and fro. The same way when you want to work on a car, hata kama umeengage the handbrake, you usually put a wedge. Kama sana sana unaona watu wanaweka mawe hapo nyuma ya tire so that the car does not move to and fro. It is the same concept. You put this on a specific part of that workpiece, and it is kept on a parallel plane by slipping these wedges at an appropriate position, so that the datum of that workpiece is still it is maintained. That datum, it is maintained relative to the reference surface. In this case, if you're using a surface table, so you can use a jack as well to support your workpiece. Are you together? Kama tuko pamoja, please unmute and say that I'm present. Naona ni wewe tu, haina shida, tutaendelea. Now we have an angle plate. An angle plate is what we use, for example, if I want to position my workpiece 90 degrees to the reference table or the surface table. For example, this is my surface table, and I want to make sure that I want to mark, or I want to make markings on my workpiece, but I want it 90 degrees to this surface table. Yeah. So what I will do is I will clamp that workpiece on this angle plate, because this angle plate has been machined accurately to be flat, to be square, and to be parallel. This angle will be 90 degrees. So I will clamp. These slots are provided so that it is easy to clamp your workpiece. So nitachukua hii angle plate, nikitumia mashimo nitashikilia my workpiece. So they can be plain as this one, or it can be adjustable, kitu ambayo inaweza kuwa foldable, or you can fold it or unfold it ili ikuwe 90 degrees. So we use it to ensure that when we are working on our workpiece and we want it 90 degrees to the surface, then we will clamp our workpiece on this face. So if I take kwa mfano this, we have a metal workpiece, a sheet metal that wants to be marked, inataka kuchorwa laini. So what this guy is doing is he's using a clamp, this clamp over here, and holding together and clamping this workpiece against the workpiece, the angle plate, and you'll see that it is 90 degrees to this reference table ambayo iko hapo chini. That is the purpose of an angle plate. Now we have V-blocks. V-blocks, so far what we've been seeing are rectangular or square workpieces that need to be marked or designed, or lines need to be drawn on them. Now if I have a cylindrical or a circular workpiece, then what I use is a V-block to hold it in place. So the larger types of V-blocks are usually made from cast iron, and these small ones are usually made from hardened steel, and they usually come with a clamp. So they come with zinakuja zikiwa mbili. You have the V block, which is V, and a clamp for holding that workpiece, as you can see in this diagram. Now this the faces of these V blocks are usually machined to a high degree of accuracy, flatness and squareness. Na pia their flatness and their parallelism have been machined vizuri sana, such that this V, this 90 degree V, is at the center of these two faces. Hii V iko katikati of these two faces. Are you together? So if I want to mark my workpiece, then I can be able to draw, for example, a line around this workpiece by holding this workpiece in between that V groove, and using this U clamp to hold it into place. So V blocks are used to hold together to secure circular workpieces when marking out. Now we have an engineer square. Now, this is one of the most important tools that you'll find in a workshop or in the industry. Now if I want to set the workpiece square to the reference surface, I will use this this engineer square or a tri-square, or if I want to scribe line square to the datum edge, then I will use this engineer square. Now we have a blade which is made of hardened steel, and we have a stock which is, I think, bronze. I'm not sure. This is known as the stock. This is the blade. Now this angle between the stock and the blade is 90 degrees. And if I want to make a line that is perpendicular, I want to draw a line that is perpendicular to the datum or the reference edge. And this, for example, this is our reference edge. Then I will use a tri-square. Kwa sababu if I try to draw this with a ruler, I will still get a straight line if I use a ruler, but inaweza kuwa I can slip line ikaenda combo. It will still be straight, but it won't be perpendicular to my reference edge. So I use a tri-square. I don't know if you're able to see the video that I sent. Kwa mfano, if I'm drilling a hole, I'm using a vertical drill ambayo inatoka from up, and I want to drill. This is my drill, and this is my workpiece. For me to ensure that my drill is at 90 degrees to my workpiece, I will use this tri-square. Ili nisipate nafanya natumia drill na hiyo drill bit iko at an angle. I do not want to drill a hole ambayo inaenda combo. So I use this tri-square to ensure that I use it to test for the squareness and to ensure that these lines that I'm drawing, these tools that I'm using, are perpendicular to the reference edge, to the datum. Now we have another important tool which is known as a combination set. Now a combination set has three heads. We have this head which is known as the square head. We have this head which is known as the protractor head, and we have this head which is known as square head, protractor head, and then we have the center head. This is known as the center head. Now this protractor head is used when I want to make lines that are angular that are at an angle on the workpiece. If I want to draw a line that is at an angle, then I use this protractor head. Now something very important to note in this combination set is that these heads are movable. They are not fixed on this steel rule. They are movable. This ruler is a steel rule. Ni ruler ambayo is a steel, and then it's a steel rule. And these heads have slots in katikati yake, such that I can be able to slot them on the steel rule and lock using these nuts. Nikilock, then it becomes immovable. If I want to remove it, if I want to slide it to another position, then I unlock it and move it. Now for a protractor head, there has nile protractor ya kawaida ambayo tunapata kwa set. The head it has graduations from 0 degrees to 180 degrees, and then it is adjustable such that if I want to draw, let's say, a line that is 50 degrees, then I'll move this head to where 50 degrees is, lock this nut, put my workpiece along this line. I'll put my workpiece along this edge, and then using that ruler, then I will draw a line on that workpiece that is 50 degrees. If I want, that is, we use that to draw lines that are at an angle to draw lines that are at an angle. This square head will incorporate the same work kama ile tri-square. Ile tri-square that we saw that is used to draw perpendicular lines, but this edge is used to draw the perpendicular line. This edge is used to draw lines that are 45 degrees. But this square head is not as accurate as this tri-square, kwa sababu this square head, remember, it is movable. That is why it is imewekwa spirit level. I don't know whether you can be able to see it here. Kuna spirit level that will help you to determine whether the square head is straight. Now we have the center head. This is used for circular workpieces, round bars. If I want to identify the center of that workpiece, then I will use this center head. So I will put my workpiece hapo. And the the blade of this the ruler will pass at the center of the V, and it is used to mark the center of that circular workpiece. So this blade will pass at the center of that center head, and then it will be used to mark the center of that workpiece. So use this for marking lines at an angle. We use this. This is used the same way as a tri-square, and this is used to identify centers of circular or round bars. A scriber. A scriber is what we use to now draw the lines on the metal workpieces or the workpieces. For I'm sure you've seen in watu ambao wanafanya woodwork wanatumianga labda penseli, watu wanafanya masonry wanatumia chokaa. When you're doing on a workpiece, we use scriber. As you can see, it has a sharp edge. There is a sharp edge on one end that is at an angle. We use that. This is usually made from hardened steel, and this is known as a pocket square, a pocket scriber. But this is the most common one that you will see, kwa sababu it has this bent edge. Both ends are sharp, but this it has a bent edge. So this bent end is used to scribe lines where the straight end cannot reach. Because for mfano, if you want to scribe around corners or in holes or grooves, mahali ambapo the straight edge cannot reach, then we use this bent edge. But both of them are scribers. This is known as a pocket kwa sababu mnaweza kwa mfuko, ni kama kalamu, una click hapa, this edge inatokea. But this is what you'll find common in most workshops. So we use this to draw the lines or scratch the lines on the workpiece. Now a surface gauge. Now a surface gauge incorporates a shaft, which sana is a scale. It can be a vernier scale or just a normal scale, and then it has a scriber that is attached to it. Now we use this to mark out lines that are on the to mark out lines on a workpiece parallel to the surface, to the reference surface. What do I mean? If I have a reference surface here, and my workpiece is at a certain height, parallel to the workpiece. Kwa mfano, it has been attached to the lathe machine or whatever machine. It is at a height parallel to the reference surface. Then I will use this surface gauge. I will attach it to the reference surface, then adjust this scriber to reach that height that I want. Then I can be able to mark the workpiece. Are we together? Yeah. So it is used in conjunction with this scale, which can be a steel rule, which has a normal scale, ama it can be a vernier scale, depends. But sana it is a steel rule. San zingine it doesn't even have a scale. It is just you to estimate where you want this scriber to be. Now, a disadvantage of using a surface gauge is this mahali pa kushikilia that scriber. If you do not tighten this vizuri, then it moves, itacheza. So if you're going to be marking your workpiece, you have to ensure that this scriber is securely attached by using this knob, this screw over here. Kwa mfano, if I want to make a marking on a workpiece ambayo nimeweka kwa lathe machine, badala ya kutoa ile workpiece from the lathe machine ipeleke niweke chini ni mark, no, what I'll do is I'll take this surface gauge, place it somewhere that is straight, a place where I can say it's a reference surface, then adjust that height of the scriber, and then I can be able to mark that place kwa hiyo workpiece that I want to cut or machine or something of the sort. So this is what we refer to as a surface gauge. Now a divider. A divider is the same one that you'll see ile ambayo unatumia katika set. We use this to be able to transfer measurements from the scale. Kwa mfano, if I have from a scale to the workpiece. For example, I want to mark 10 centimeters on the workpiece. So I'll take this divider, nifungue, measure 10 centimeters on my ruler, my steel rule, then using that length, then I'll go transfer by marking it using the dividers on the workpiece. It is also used for drawing circles and arcs on the workpiece. If I want to draw a circle that is 10 centimeters in diameter, I'll go nipanue my divider, measure 5 centimeters, then use it to draw a circle or an arc. I can also use it to measure distance between 2 points on the workpiece. If I want to get accurate readings from the workpiece, I'll go using these two legs in the panuen, place each leg at the 2 points I want to measure, and then transfer that reading onto the scale so that I can see the distance between those two points. Now there is a limitation to these dividers. There's the maximum of the maximum distance or the maximum diameter of the circle I can be able to use to draw or an arc is 150 millimeters. So beyond that, hii kitu itavunjika, the pivot or the fulcrum will break. So that is why we have trammels. Now we use trammels if you want to draw circles that are ni kubwa, because you'll find that these points, these edges are adjustable using these screws over here. So if I want to draw an arc or a circle that is more than 150, let's say 500 millimeters in diameter, so I'll just adjust these 2 points so that it can fit the radius of which, when I draw a circle or an arc, will give me 500 millimeters. And in this case I want a radius of 25 to 50 millimeters. So we use trammels to be able to draw or scribe points, or to draw circles that are larger circles or arcs. Now these points, or these scribing points, are usually adjusted along a beam that has calibrations, or that has this scale has been these divisions in scale that have been inscribed on a beam, that when I want to draw a certain arc or a circle of a certain dimension, then I can be able to adjust these scribing points along that scale. Now for a divider we have two types. We have a spring type and we have a normal type, and this is a spring type. Kuna spring hapa katikati between the legs to ensure that you can be able to adjust it. There is a nut, there is a spring, we have, or a screw, we have the fulcrum. So you open this by unscrewing ama unwinding this screw, inafunguka. Unikitaka kufunga na screw. But you have the normal type kama ile ambayo in a set. I just open and close normally using my hands. Now we have a vernier scale, a vernier height gauge, and that is the reason why I've sent that video, so that you can be able to read ama to interpret okay, wacha tu niachie hapo. What I can do for now is I will send the video that I took with the other class, so that kwa sababu I will not be able to cover this topic completely, then use that video ambayo nilichukua I'll send the video that I'm recording right now, and then we will see how to finish this topic next time.